Okay, hello everyone. This is Nikolaos Vasiloglou, Nick the Greek, also as known in the Atlanta community, and a very big influencer. I don't know, but I feel very uncomfortable giving the talk from my house. I felt like I had an easier time giving it in person. So we give it another minute for people to gather. We have 13 and growing. I have to say, last year I was the last speaker, and I complained to Amelia about that. So this year she made me be the last of my session, but probably the second to last on the conference. Okay, so it's 4:21 here in Atlanta. And probably different times around the world. And today we are going to review I created a poll and I don't know how to make my poll available. Take control, poll. Enable poll, okay. Poop. Everybody see the poll? Okay, I just put a poll on, so we know what kind of audience we're having. Okay, I believe you can see it. Let's see what's happening in the chat. Okay, so I'm just gonna. I think the poll is live. Can you tell me if you are seeing the poll? If you can vote. I see some people are voting. Okay, it's called "How Technical Are You?" because I want to adapt my my talk based on the technicality of the audience. This is one of the perks we're having by doing a conference virtually. I'm not going to ask you raise your hand, although maybe we should do that. I like this idea. Anyway, machine reading in 2020. A lot of things have happened in the current year. So it's a long presentation. I posted all of it, but I'm not going to go through all of it because it's too long. So, okay. In the days of conventional machine learning, people used to use bag of words, word embeddings, classifiers based on specific features for answer a specific question. Sometimes we call this tagging. And topic modeling were very popular. And in general, none of these conventional machine reading techniques could understand text. They have been very successful, but they are very primitive. Apparently, the problem was that these methods, either they were taking poll is complete. Oh, sorry. Well, anyway. Maybe that. I don't know. We'll see the poll later on. I don't know why it says complete. Sorry, I shouldn't get distracted with that. It says it's live. Anyway, the biggest problem was that the documents are very long sequences, and previous methods either they didn't really take that into consideration, or they could have a very limited focus. They could look, maybe a few words before the current word and a few words after. And recently we have these two very interesting mechanisms that were invented. The attention mechanism is not very recent, about 5-6 years old, but the transformer, it's about 3 years old. They kind of like revolutionized our approach to machine reading. And when we talk about machine reading, we cannot ignore the king or the queen of machine reading, depends on how you look at it, GPT, generative pre-trained models. and everything started 3 years ago from GPT-1. Now it is basically invented by OpenAI, although Elon Musk right now disagrees. He thinks that OpenAI is closing it by giving it to Microsoft. Anyway, the main idea, for those of you who understand probabilities, we are trying to predict the n next words given the n previous words. And when you are talking about complicated text, you read your n to be like you're trying to predict very far away in the future, and you really need to know very much in the past. So the very first paper that is very important, and if you want, if you need, you should, if you have the time, you should study. Is a paper back in 2017. It says attention is all you need. So it was kind of like the day where LSTM kind of like lost their glory, and they become replaced by attention, by transformers. Basically, that's the birth of the transformer. I won't go deeply into the math, but I'm just going to show you a diagram that this is your output. And I don't know if my mouse is, you can see my mouse. But we see the orange is the output and the gray nodes are the input. Okay. And while you're trying to predict your output, you need to see somehow all the input, and you want to see what was your previous output. Okay. But also, so this is kind of like the attention mechanism, the one that connects the orange, disks with gray ones. But also in the input, in order to understand what is happening, you somehow want to create connections between the input, and this is called self-attention. Unfortunately, we don't have time to go through all of this, and just wanted to give here something that when you're applying attention, it generates a new sequence, and then you can combine all the sequences, and you can make even more complicated things. Now, what you probably need to keep from this presentation is that the attention mechanism does kind of like a pairwise comparison between input and output. So it is it's quadratic in terms of length. And of course, there are some other networks that they look like attention, they're not attention, but that's also a nice paper. It's called the relational neural network. Very interesting. That was from DeepMind. Again, we're doing a review over here. And what is interesting is when you are trying to make predictions, you can see over here that this is the red word that you're trying to predict, and the blue one gives you the intensity. This is yes, it's the red one is generated, and it is affected. It shows you which words from the past are affecting the generation of the red word. Okay, so now we have the attention. This is the diagram of the transformer. We don't have time to go through that. It's a very complicated network, as you can see over here. Probably there's some very good resources that you can read on the web. Excellent, and I think they're on the Distill, and there's lots of blogs that they go step by step about how to code them, and about how to work with them. Okay, so there's also, maybe we should skip that, the Longformer. Let's not talk about the Longformer, but let's go and talk about transformers in action. Or maybe I should. The Longformers are basically transformers that, as I explained, the transformers here they look, they use attention that, looks n words in the past, from the past, and maybe n words from the future, and that's quadratic. And in some cases, people are using other patterns where, like, for example, over here, they don't really look exactly all the words in the past, but they look, every other word in the past. And the Longformer is something that is trying to look really, really away, really many words away from where you are right now, so it can get better results. Also, very interesting problem, interesting idea, again, from University of Washington and annxn. Transformers in action now. The very first application was actually not GPT-1, it was BERT. That was from Google, and then OpenAI responded with the GPT-1. Let's not get into the details of how GPT-1 works, but it had some impressive results in terms of prediction. And then GPT-2 came along, and you might wonder, what was the difference between GPT-1 and GPT-2? Okay, let's see the differences, which is the thing that's very important over here. So first of all, it has an order of magnitude more parameters. The GPT-1 has about, let's say, on the order of 150 million parameters at a neural network. The GPT-2 is about 10 billion parameters. Okay. Now, GPT-1 and GPT-2, they are trained on some huge corpuses. It was something in the order of the whole web, a web dump, let's say 40%. I think GPT-1 was 10%, GPT-2 was 40%, 60%, something like that. And then they added books, and they added a lot of other documents in order to train it. So surprisingly, if you read this paper, most of the work doesn't really go to the architecture, but goes into preparing the documents. Now, the GPT-1 was very interesting. What they did, basically, they did exactly the same thing that you do in Word2Vec, okay? They were trying, given a set of past words, to predict the next K words. Okay, they use skip connections and skip grams, all that stuff. And then they took these embeddings, and if they had an application, they used transfer learning, like they used another network on top of it to train it for a specific task. Okay, so nothing really fancy, you all know this concept. Like, what made the difference was the size of the network and the training material. Okay, and here you see some impressive results for GPT-2. Now, in GPT-2, what they did is they only trained in an unsupervised way, and then when they wanted to do, let's say, machine translation, or when they wanted to do, I don't know, question answering, they would use what we call zero-shot learning, which means that they wouldn't really retrain the network. They just did it unsupervised, and then they asked, how does it behave in, can this thing answer questions? And surprisingly, it was able to beat anything else that was supervised. Now, in GPT-3, they went completely unsupervised, and again, they went one order of magnitude higher in terms of parameters. So now I think GPT-3 is 150 billion parameters. Now, keep in mind, they trained it on something else on the order of, so that's about, I don't know, 5-6 terabytes of memory, 170 billion parameters. And the network that they trained it probably was less than that. Like, if you think about the web and GitHub, they also trained it on GitHub, so it can actually code. Anything they found, they put it in. It was on the order of a few terabytes. So you can think of GPT-3 as like an index of the web, as a web 2. Google takes the web and creates this inverted list and does keyword search. They took the whole web, and they they indexed it sort of with a neural network, which I think is very impressive. In fact, there's a video on YouTube with 15 applications of GPT-3, and one of them is a search engine based completely on GPT-3. They also provided more benchmarks, like this paper is 70 pages, and they did a lot of fine-tuning. Now, what they did over here is they said, okay, we don't really have to go to zero shot, but we'll go to few shot, which means that we're going to show some examples. We're not going to retrain the network with some new label data. We're giving, I mean, I'll show you how it is over here. Here, this is the zero shot task, where you just tell your task, you just literally, this is what you give to GPT-3, translate English to French, you know, colon, you put the word in French and then the arrow, and then it will give you the translation. So that's like a few shot, a zero shot. In the few shot, you give a few examples. Like this is, you just, again, every time you're just passing a document to GPT, where you're giving some examples, and then you say, okay, now you see what I'm trying to do it by yourself. And then, you know, you can always, if you want, like here, the one shot, you can, you know, you give one example. If you want, you can retrain your network with more example, like do the traditional transfer learning, but you don't have to. Now here, and you know, you can look at the slides I put, and also you can, the slides are from the paper. You can look at several examples of question answering. There is a lot of, you know, I find this fascinating that it can do word unscrambling. You give it a word and it finds the, it can unscramble the word. It can do translation. It can do document understanding, where you basically ask a question. It finds that here it's like a data set, and it finds that it has a question, the number 4. It can even do addition. So this is fill in the blank, but let me find the one that is, sorry, one shot question answering. There's one. Okay, sorry, I went too far away. I think this one is, because I can see the slides very well. Yeah, so here it did reasoning, because you're asking a question and it does addition, but there is, may have skipped it. Anyway, it doesn't matter. You can literally ask it questions. Yeah, here it is. Addition as question answering, which is fascinating. And for those of you who are more into mathematics, there's an extension of GPT-3 that can actually do work with mathematical proofs. So it hasn't really proved the Pythagorean theorem yet, but soon it will be able. It can prove some other theorems. Anyway, we don't have to go through that. Now, I have 2 minutes left, and I want to take you to a different set of document understanding, which is called differential reasoning. And you know, basically what they do is they take the question, like you might have seen that, you've seen this recent framework where you type a natural language query and it translates that to SQL, okay? And then you execute that versus SQL. Well, actually, believe it or not, you can do that with text. So what these neural module networks are doing is that basically they're taking your question, they are translating into you know, into a program, okay, like a SQL query. If you think the SQL query as a program, and that program runs against the text, and it can, and then it gives you the answer. It takes the, you know, it gives you the answer. So in this particular case, who kicked the longest field goal in the second quarter translates into that. Then it runs these operations, and it gives you the answer. You know, it is possible, and you know, I'm not gonna. Have less than a minute according to NMITS. By the way, we love NMITS. I'm saying that because I belong to that team, and I'm very happy that it goes so smoothly. It's an amazing experience for me to use it. So, you know, instead of having a text, you can take your text, you know, store it into predicates. You know, Nick was born in Athens. Amelia almost likes Nick. and stuff like that. And then you can execute logical expressions. Is Nick friends with Amelia, or will Nick be a speaker next year, and things like that. So I'll stop here, and it is custom for me to talk about books. I didn't put them in the presentation, but I'll just show you 3 books that I'm reading right now. 12 Tomorrows, excellent book from MIT Press. This is imagining our future with the current technology. So this is fiction based on the current technology. Obviously, one of them is AI, and the other is Bitcoin and other stuff. This is a 40-year-old book now, the Gödel Esser Bach. This is the old version. It is inspiring. If you don't want to read the 700 pages, there was an MIT course that you can find it online on YouTube. They made a course out of it. This is the epitome of AI. This is a very inspiring book for computer scientists. And the last one, because I kind of got a little bit under the weather with a serious infection, Microbes, excellent book. I learned a lot of things about these tiny organisms that were much more dangerous than AI for me. Okay, thank you so much. And I'm so happy that I can keep my session open as much as I want, because nobody can set the microphone to me. Okay, so I don't know if we had any questions. No, everybody's gone. No, everybody's not gone, but nobody has questions. So thank you so very much, and I'm counting 10, 9, 8, 7, 6, 5, 4, 1, 0. Signing off. I go backstage. What do I do? I don't know how to end the session. Here it is. Oh, the books that I'm recommending. Okay, let me write them here. 12 Tomorrows by MIT. And then the other one is Gödel Esser Bach. This one has a video. And the last one was Microbes by Philip Patterson, because there's a lot. Okay. Is there any option to use GPT? Well, I think Microsoft will probably make it publicly, well, publicly, they will price it available. It's going to be an option. I think we also have breakout rooms, which we can, oh, there's no available. Okay, we can continue here. But anyway, I think I have to sign off. Bye-bye.